Dear scholars, I hope you are fine. After discussing about the safety rules and the regulation pertaining to the workshop, after discussing some signboards and symbols, now let us move to another topic, which is measuring tools and instruments. Whenever you are doing any activity in engineering field, you need to measure. You need to know the exact quantity of what you are doing in terms of kilograms, in terms of length, in terms of diameter, in terms of straightness, in terms of height, in terms of depth, and others. So the quantity is very important in engineering aspect, as it will give you the base for the quality assurance, the base for the fitness, the base for the accuracy and precision. So, in order to determine different size and shape of the components, we must learn about different engineering measuring tools and equipment that will help us in determining and finding some measurement or some values pertaining to different parts or materials. So, in terms of measurement, we have at least we have several categories of measurement. The first one is the linear measurement. When we say a linear measurement, it means we measure a linear values such as length, height, depth, and others. So in this category, we have steel ruler. The steel ruler is a simple measuring instrument consisting of a long, thin metal strip with a marked scale of unit division. The steel ruler are manufactured in a variety of types and length, each of which is designed for measuring or laying out different work. They are available in length from 100 millimeter to 1000 millimeter. So this is a measuring tool, and it is just like a strip, a flat strip having a marking out with dimensions. So you can see here it is 10 inches, 11 inches, and 1 foot or 12 inches. You have the measurement in millimeters as shown here. So all these are the ruler, a steel ruler, and it is called a steel ruler because it is made from stainless steel materials that are not corroded, not get by rust, and they allow a, a deflection without any kind of deformation. Sorry. So we use these steel rulers to measure the length of different components, different parts, different workpieces, different machining parts. They measure the length with close tolerance and accuracy, but not more precise. So we have measuring tools. These are also the device that are used to measure the length, the measuring tape, sorry, the measuring tape that is also used to measure the length of a workpiece or a machining part. This is close to a steel ruler. The only difference is that it can be expanded, you can lengthen it, and then you can roll it up during the storage, and they are provided with different lengths more than the length of the steel ruler. And the same as the steel ruler, it has the dimension in centimeters, dimension in millimeters, and the dimension in inches. So the main purpose and the function of where this is used is similar to the stele ruler. It is just a matter of the length of this compared to the stele ruler and some minor flexibility issues and the simplicity of carrying. And we then have a spirit level. This is another category of the measuring instrument. This is actually used to measure the flatness of the surface. It is used to measure to how extent the surface is flat, the surface is horizontal with respect to the ground, how to what extent the surface is vertical with respect to the ground, and also it can be used to measure 45 degrees, sorry, 45 degrees. For instance, here we have, this is used to measure the vertical axis. This is used to measure the horizontal axis, and this is used to measure 45 degrees from the ground. So when you are using, you will see a bubble of a water bubble or air bubble in the water. When this air bubble lies between these two black marks, then your surface is horizontal. The same applies to when you are measuring the vertical surface, then it should also lies here. The same applies to when you are measuring at 45 degrees. So the main and the basic function of this is to measure the surface for its horizontal accuracy, vertical, and 45 degrees. This is not very common for mechanical engineers, but it is also used in some cases. It is very common for civil engineers and construction engineers. So we have another item, which is a micrometer screw gauge. This is a device, a measuring device or a measuring tool that is used to measure the diameter of a material or a diameter of workpiece. So it basically have the anvil, the spindle, and here between is where you put your workpiece that you would want to measure the diameter. You then tighten up the thimble so that the spindle moves toward the workpiece. When it tightens, then you read you can also lock the spindle so that it won't affect the dimensions. And this sleeve is used to show up the dimensions. Then for this vernier micrometer screw gauge, we have some types. The first one is an outside micrometer, which is the one which is shown in the picture there. The second one is inside micrometer, and the third one is depth micrometer. So what is actually the difference is whether is the device or the tool being applied on the workpiece. The outside micrometer is used to measure the outside diameter of the workpiece or of your material or the part. The inside micrometer is used to measure the inside diameter of the workpiece or of the material. So for instance here, you put your part here and you insert these two jaws inside the the diameter of that particular workpiece you are going to measure. Then you rotate the thimble so that these jaws expand and tighten up inside the workpiece you are measuring. Then you read your dimensions and you get the dimensions. The third one is the depth micrometer. This depth micrometer is used to measure the depth of the hole. How deep is the hole? So we are going to insert this pin inside the hole, and this one should be a guide on the top of the hole. So how much the pin has been inserted is the measure of the depth of the part or that hole. This is how it is used. You can see these flanges are lying on the surface of the part of the material, and then the pin has been inserted inside the hole to measure the depth of that particular hole. Then we have some calipers. These are a simple instrument or simple tools that are used to measure whether the inside diameters or the outside diameter, but they are not used by themselves. They are not a standalone devices. They must be used with other measuring devices. For instance, this one is used to measure the diameter. So you put your workpiece and you close it within these two jaws. Then you remove a workpiece and measure the distance between the first jaw and the second jaw to know the diameter of the workpiece that you have been measuring. So you can also use to measure the inside diameter, and the same as the previous one, you must also measure, after removing a workpiece, you have to measure the distance between the two jaws, whether using a ruler or a tape measure or any other similar measuring device to know the exact dimension. So in most cases, these do not stand by themselves. They must be used in company with other measuring devices. Otherwise, they can be used to transfer the dimension from one place to another. Then we have a vernier caliper. This is used for measuring the external and internal dimension as well as the depth. This is similar to micrometer screw gauge, except that this can measure multiple dimension with a single tool. For instance, here we can measure the internal diameter, here we can measure an external diameter, and here you can measure the depth of the hole or the workpiece. So it is actually used to measure some dimension, but all are the linear dimensions. This vernier caliper consists of several parts. We have the internal jaws that is used for measuring the internal diameter of a workpiece. We have external jaws that is used to measure the external diameter of the workpiece. We have a locking screw that is used to lock up the moving jaw after measuring so that it cannot affect the dimension, so that when you are reading it cannot move from where you have set to another unnecessary point. Then we have a scale. We have two types of scales. We have a metric scale and we have imperial scale, and we also have a main scale and a vernier scale. So to start with the main and vernier, the one starting from here up to here is known as a main scale. This one from this point to that point, or from this point to that point, is known as a vernier scale. But in both vernier scale and main scale, we have two categories of scales. We have the lower one, which is used for metric. We have the upper one, which is used for imperial or British scale or British units. The same here, the upper one is used for imperial or British units, and the lower one is used for metric units. So also we have what is known as the accuracy or the precision of that particular vernier caliper. If you see here, there is this 0.001 inch. That means every unit, every point, these small points, every point represents 0.001 inch. So as this value becomes lower, the more your vernier caliper becomes accurate and precise. So this is how you can measure the internal diameter, how you can measure the external diameter, and this is how you can measure the depth. So after measuring depth, then you read both main scale and vernier scale as shown in the following video. So look at this video, start from this video, and then we shall come back and conclude. So here is the video. Please be attentive, listen to it, follow up very closely, and then we shall do an exercise on how to measure those units, how to use a vernier caliper to measure units. Okay, it doesn't open up. Let's find another way.
That is 0.02 millimeters. See how 1 divided by 50 equals 0.02? Now, the first thing we're going to measure with our vernier caliper is nothing. That's right, we'll measure 0. It may sound like a silly thing to do, but we're going to do it for a couple of reasons. Let's do it and you'll see what I mean. You see, when the calipers are fully closed, measuring 0 width, you can see the places where you can take measurements. These surfaces are where the two parts of the calipers line up. You'll also notice that there are gaps in a couple of places on the calipers. These are not places to take measurements, so don't mess up by putting something in one of those gaps. Now, with the calipers closed, you can see where you're supposed to read the main scale. There are two scales on a vernier caliper, the main scale and the vernier scale. I'm going to erase the vernier scale and let you just look at the main scale first. You see, the 0 mark points to the place where you're supposed to read the main scale. Right now, it points to 0. Do you see that? Good. Let's read the main scale first. It's super easy. I'll close the calipers on this workpiece, and we'll see what the main scale says. These marks represent whole millimeters. So the reading is 1, 2, 3, 4, 5 millimeters. Just be sure to look at the 0 mark and not at this part. That's a common mistake, and it'll give you the wrong reading. So the reading is 5 millimeters. That's pretty easy, right? Before we move on to the vernier scale, let me show you what it's going to tell us, okay? Let's say when we looked at the main scale, the reading wasn't right on the mark like it was last time. Let's say it looked like this. See how the mark is between 5 and 6 millimeters? It looks like it's a little beyond halfway. You see, the vernier scale is going to tell us almost exactly how far over the mark is. Okay, you're ready to see the vernier scale, but I'm only going to draw the main part of it first. Now, you see the marks number from 0 to 10. Each of these marks represents a tenth of a millimeter. They're going to tell us the tenths of a millimeter, and here's how they work. Look carefully, and you will notice that one of the marks on the vernier scale lines up better with the main scale marks than the others. Which one looks like it lines up best to you? I'll zoom in and let you look. Let me show you a hint about where to look on the vernier scale to see where the marks line up. You see how our pointer was a little more than halfway between marks? That means the vernier scale will line up a little past halfway. Now, do you see the mark that lines up better than the rest? It looks like the 7 is lining up. The 7 means 0.7 millimeters. But this caliper can measure even more accurately than that. I'll redraw all the marks and let you look again. Now, see that the mark next to the 7 lines up best. But what is the value of that mark? Remember how this caliper had a label that said 0.02 on it? That is what each mark is, 0.02 millimeters. Let's count up on the vernier scale to be sure we've got it. This 6 would be 0.16. The next mark, 0.62, then 0.64, 0.66, 0.68, 0.70, then 0.72. The reading is 5.72 millimeters. Pretty neat, huh? I'm going to let you try a few. We're going to start off easy. I'm going to draw a caliper that only reads to the nearest tenth of a millimeter, just to be sure you're with me. I'm going to show you the overall picture first, then zoom in to let you see the vernier better. Okay? When you see Sparky's pause the video and write down what you think the reading is. The reading is 16.2 millimeters. Let me step you through it just in case you missed something. Here are the whole millimeters from the main scale. 10, 11, 12, 13, 14, 15, 16. Okay. And you see how the reading is just past the 16 mark? So we'll look to the front of the vernier scale for where the marks line up. And there it is, at the 0.2 mark. So the reading is 16.2 millimeters. Got it? Okay, let's go for broke and see if we can read the full 0.02 millimeter resolution. Ready for this one? Again, I'll show the whole caliper, then zoom in to let you see the vernier better. Here we go. Pause the video and write down your answer. Now, I know this is hard, so before I give the answer, I'm going to point to the place where the vernier lines up. Does that help? Take a minute and check your answer and be sure it's correct. The reading is 19.16 millimeters. Okay, let's try another one. This time I won't give any hints, but I will zoom way in so you can see the calipers really well. If you get this one, you pretty much know what's going on. Pause the video and make sure you can read the whole millimeters. Did you say 12 millimeters? Okay, let's do the hard part and read the vernier scale. I'll zoom in and let you take a closer look. But first, remember the trick? See how the reading is beyond halfway between the marks? That means we need to look on the high side of the vernier scale. I'll slide the view down there and let you look. Now here we go. Pause the video and look carefully. The mark that lines up best is here. Now, what number is that? This is the 0.7 mark. So 0.72, 4, 6. The answer is 12.76. That's about all the time we have for now. Vernier calipers are hard to read, but with a little practice, I'm sure you'll be able to do it without too much trouble. I'm Bob Welds, and these are Weld Notes.
Okay, so I hope you have carefully investigated what has been taught in the video. Yes, now let's see this dimension. Can you read this from the knowledge you have got in the last video? What is the dimension here? Have a time and quickly observe what is the dimension. So we have main scale. It is 1 millimeter, 2, 3, 4, 5, 6, 7, 8, 9, 10 millimeters, 11 millimeters. So the vernier scale starts after 11 millimeters, and if you observe it very carefully, you find that the vernier scale start, it's almost above the half of the main scale. So our dimension must be more than 0.5. So you can just see here we have 0.6, we have this is 5. So our dimension is 11.65. Hoping that this is the one which aligns well. So if you have got the answer, then congratulations. So let's move to some application of those verniers. We have specific verniers that actually measures specifically a certain parameter. For instance, we have the vernier height gauge that is particularly used for measuring the height of the object, and this is the one which is used to measure the height of the object, and at this point, or a pointer scrubber is the one which is used to point the dimension, as you see here. So from the ground up to this dimension, up to this point, the dimension is shown here. So all the principles, how to use it, how to read is the same. The only difference is whether it is applied, and this is more accurate and precise in measuring the height because it is specifically designed to measure the height of the material. We have the vernier dial caliper, which is used to measure the length of the diameter, but instead of using the linear scale, it uses the dial gauge to measure the vernier scale. So instead of having that small vernier scale, this one we use a dial indicator. We have a dial indicator itself. This is the linear mechanical movement of the stylus is magnified and transfers to the rotation of pointer as shown in figure 12. The accuracy of dial indicator can be up to 0.01 millimeter, as you can see here. So you measure the dimensions here. So if maybe a part is rotating, when the part is rotating, it just touch this point, then this will read. Or if you want to measure the height of something from this ground up to this level, when this point touches to the object, it will give you the dimensions on the dial indicator. So it is used to measure the dimensions of some objects. We shall see during practical of how to use this dial indicator. We have what is known as a feeler gauge. This is a kind of strips or fine strips that is used to measure the gap or the thickness of a gap. It mostly used like when you are measuring the sparking plug gap, when you are measuring a certain clearance between one piece and another, or one part of the machine and another. So they are very useful in engineering, and they are given in different thicknesses. So you find the numbers here, whether in British or in metric, but all numbers are showing how thick this strip is, and its thickness is the one which measures the gap. For instance, when you want to measure a gap between one part and another, you do a try and error. You insert this strip. When it fits, that means you read the dimension on the strip, and when you find this reading, it shows how much the gap is. When it is big compared to the strip, compared to the gap, then you find the smaller one, and if you find the smaller compared to the gap, then you find the bigger one until you find the best match, and that the best match is the one which you read its dimension, and it is the exact dimension of that particular gap. They are found in metrics and in British, but all of them have the same principle of operation. We have a protector that is used to measure the degree. I think it's well known. We use to measure the degree or the angle of a particular material or a part. Then we have a wire gauge. The wire gauge is a device which is used to measure the diameter of the wire. Compared to the vernier caliper and micrometer screw gauge, these are also used to measure the diameter. So what you do is you insert the diameter of the wire inside these holes. So the holes which best fit to the wire is the one which you read its dimension or its readings. So according to the thickness or diameter of your wire, you do by try and error to insert to different holes until you find the best match as we did in the feeler gauge. So let's see some care and use of measuring instruments. These are just a few measuring tools and instruments. We have many and you can see a lot, but these are just some basics, and most of them have the similar principles as the mentioned ones. So it is very important that these tools should be stored well, should be cared so that they can stay longer, so that they keep measuring the accurate values, the accurate units, the precise units for their and for extended lifetime. So some few care and proper use of measuring instrument includes: the first one, never drop measuring instrument. These are precise and accurate instruments. They are delicate, and a dropping or any kind of forces can damage the tool, and therefore they may be out of the calibration. So take care of them and not allow them to drop unnecessarily. The other care and use of this measuring tool is keep it away from any other heavy components to avoid damage of measuring tool. Don't place them together. You can sometimes negligently combine or put together a measuring tool like a vernier or micrometer with heavy objects like hammer, a workpiece, or some other heavy parts. So this could damage the accuracy and the precision of the measuring tool, so don't do that. The third one is you are supposed, or you are advised, you are cautioned to avoid misusing the measuring instrument. Use them properly for the intended job, for the intended purpose, for the designed aim. Don't use it for another application that is beyond their designed aim. For instance, you use a vernier caliper for scribing, you use it for heating, etc. So don't do that. Number 4, always clean your instrument after use. This is very necessary to clean the instrument. Don't leave them with some dirt, some particles, some oils, and other unnecessary particles. And then the fifth one, after completing your work, please return the instrument to their storage place and store them properly. So when you are done with the practicals, when you are done with the use of this instrument, make sure to return them to the store, make sure to return them to where you found them. This will ensure that your working instrument or measuring instrument is safe. They can be accessed by the others easily, and also we avoid the loss and misplacing of this measuring instrument. So this is the end of our lecture pertaining to the measuring tools and equipment. We have some other instrument and measuring tools, so you can find them in the laboratory, you can find them in the workshop, you can also find them when you go for your training, IPT, industrial practical training. These are just few and the basic ones that you will be using during your practicals. Thank you.